Hi, let's look at different types of thermometer and also their properties. So here I've got a page on the note about different types. So here we've got thermistor, thermocouple, and also the very traditional kind of liquid in glass thermometer. So I would like you to try to read the textbook and try to think about the answers for the blanks here. And just by the way, in the previous page there's also a few blanks that is about thermal expansion and temperature scale, and let's just do them as well. And my hint for you to refer to the textbook should be chapter 5.02, these two pages, and also 5.03 for these two pages. So try to pause the video now and really try to read through the sentences and locate the correct answers.
A few moments later.
Okay, let's go to thermal expansion first. So this is something that we probably have done in the class, or you have at least watched the video on the playlist earlier. The idea is when you heat something up, apparently the volume will increase, it will grow bigger simply. So using the scientific terms, we can say that the reason why volume increase is because the kinetic energy. So here I just put down the abbreviation, try to spell the full words. And when you have greater kinetic energy, then it's increasing the vibration. So more vibration, or you can even say vigorous vibration. And because normally you can imagine the particle would be vibrating anyway, but then now they vibrate even more. Okay, in all direction actually. It's not just like vertical and horizontal, actually in all direction. And so they kind of take up the space more. And eventually if you look at, let's say a cube for example, at the very end, very edge of each side, if they all take up just a tiny bit extra space, then apparently the whole thing will take up more space. Okay, so that is why we have a phenomena called thermal expansion, and it's almost happening for all different substances. There is an exception that is very famous, and that is water. When you freeze water into ice, for example, if you just simply get a cup like this, okay, and then you fill in water just barely reaching the level. Actually, I would not recommend you to do it because you may probably break the glass of the cup. But then let's say maybe if you do something like with a plastic bottle, I think that's fine. Then eventually you'll find out the ice, when it's formed, maybe after a few hours, it will go greater, alright, like more than the like beginning of your cup. So this is kind of opposite, right? So don't take that as an example for your logical thinking, because that is really an exception. The reason why it will do this is something to do with the chemical bonding, right? Why is it H2O? So something to do with that. So again, that's just an exception. Alright, next up is a temperature scale. So a number that I would recommend you to remember if you think that you are proud to be a physics student, I think you should remember this. Absolute zero, okay, is negative 273 degrees Celsius. Again, something that we mentioned earlier when I showed you the simulation. And at that time, at that temperature more precisely, all particles would not be vibrating at all. Okay, so you can't see any sort of movement. And that means the kinetic energy is literally zero. And scientists just want to kind of rectify this into a better scale so we don't have to work with positive and negative at the same time, and that's why we kind of rectify it back to something called 0K, Kelvin scale, 0K. And so by looking at this, then obviously you know how to convert. The conversion is not as complicated as Fahrenheit to degrees Celsius. It's just a linear change. So let's say a human body is usually 37 degrees Celsius, then it should be equivalent to how many K? Then apparently you can kind of calculate by seeing 37, because this is negative 200 something equal to 0, right? So you can add this, and so eventually it will be 310K. So this would be in Kelvin scale what your body temperature should be. Next up, on the video playlist I made, you should have watched a video from Veritasium talking about the origin of Celsius scale that we are using. So of course that's much more complicated than what you may think, but then eventually what we are now using is that we will call 0 degree as the temperature that is freezing or melting. We can call it ice point, so freezing or melting point of water. So when water turns into ice or ice turning into water, it has to be 0 degrees Celsius, given that is the normal standard atmosphere pressure. And similarly, it will be 100 degrees Celsius. As you know, when water boiled, it has to be 100 degrees Celsius again, given the atmospheric pressure is the one that you have normally, as in like on the sea level, for example. So we will call it, other than boiling point or condensing point, we can also call these 2 points with the name of lower fixed point and upper fixed point. It's just names, okay? So apparently because they are fixed, no matter what sort of thermometer you are using, they have to be 0 and 100 degrees Celsius, and one is lower, one is higher, so that's why it's called lower and upper fixed point respectively. So just so you know, these are referring to 0 and 100 degrees Celsius. Moving on, we finally talk about the types of thermometer and their properties. So here, the 3 kinds that we are having is thermistor, thermocouple, and liquid in glass, and they are all detect by conduction. Alright, if you're relating the heat transfer method to it, they are all conduction anyway. And it's more about the thermal energy transfer from whatever object that you're measuring to a certain place, and usually we call them probe. Okay, you will see this name quite a lot in maybe IB science, and this usually talk about the place where it is being sensitive and which is detecting on the sensor. Well, and so for liquid in glass, then it will be here. This you can also call it probe. And so notice that here these 3 kinds does not include the one that you find nowadays quite commonly, the one with radiation, where you just have to kind of beep, and check the body temperature through radiation, right? The non-contact, that kind. So for the first one, we call thermistor, and you may find, oh wow, this seems to be very complicated kind of thermometer, and you probably think you have never seen it, because here the explanation is not something that you may understand right now. It's a component where it will have low resistance in high temperature, something we'll learn next year in circuit. But then these kind of thermometer, I'm pretty sure that you have used it before. Alright, we just don't call it thermistor, thermistor thermometer. If you look at the picture, you'll find out it's just simply a clinical thermometer that I don't know, like when I was a baby, I got this. Alright, so this is something that I guess everyone's home probably you have it. Instead of having liquid in glass, I think for baby especially, or young children especially, this will be better because it's kind of digital. So you just read the value, and the potential hazard with liquid in glass is, they may just bite it, and apparently that's not going to be good. The second one is called thermocouple, and I am 100% sure that you have never used it or know about it before, for 100%, because when I was a student, I didn't know this as well. Like, there's no way that you will use it in daily lives, because usually it's quite expensive, and therefore it's more for industrial use or scientific experiment. And in terms of the properties, which is something that we'll mention later, like sensitivity and range, this one usually will outplay outplayed the liquid in glass thermometer, and apparently there's a reason why it's more expensive, and internally it's more complicated as well. So yeah, let me just briefly explain to you. The working principle of thermocouple is kind of magical because it's based on a very special physics phenomena. That is, when you have two different metal put together, like they kind of contact together, and there's actually a picture in the textbook. You can kind of refer to this, so you can here see that they are kind of having two wires on this side. This is called the hot junction, and here is called the cold junction. So the basic idea is for these two plates, if there's a temperature difference, then there's a physics phenomenon happen, that is, they will cause a voltage, right? So normally if you don't do anything, there's no voltage, like as in if you don't connect your battery, there's nothing happening in the circuit. But then if you connect the battery, then there's a voltage. So this is a very special phenomena that happen, and using this you can kind of map the number, right? So because when you have great temperature difference, then you have greater voltage difference, which cause the current to flow. So apparently if you have more voltage, then more current. So eventually by measuring current, then you know how much temperature difference it will be, and that's why we need to have the known temperature as a reference, and then you just maybe doing a addition or subtraction accordingly. And here I said a word called galvanometer. You don't have to memorize that for now because we'll get to talk more about these things in circuit. But then galvanometer, in case you are interested, is just simply similar to ammeter. It's just a more sensitive ammeter that can measure either way, so positive or negative way. So here is a brief video that I'll also put that on the playlist, but I'll just show you the highlights, because if you watch the whole thing it might be boring, and then I just show you what you need to look at. So here you can see here is the hot junction, and the cold junction is kind of like hidden already. So on the meter, this is called the multimeter, to measure the current or voltage basically. So you can see it's 0 because before that, alright, nothing is here. So now what this guy is trying to do is simply try to use a lighter and measure the temperature eventually. Alright, so you can see once the lighter is getting close to the junction, or the probe you may call, the number increase already. So yeah, it keeps increasing because the heat will take time to transfer from the flame to the wire itself. Alright, and now it's decreasing because it's cooling it down. And you may ask, hey, what happened to temperature then? Because this is like 10 or something, right? It doesn't make sense if temperature is simply 10 degrees Celsius. So what happened here, alright, is that in the past, alright, this is a really old video by the way, 2010, but I think maybe this video is even older than 2010. This is a reference table. So in the past, when computer is not so accessible, and also the device are not so advanced, what people may need to do is, by looking at a certain number, they have to go and check what is that correspond to the another number. So here what he will need to do is, assuming the cold junction, the known temperature is 0 degree Celsius, then I think somewhere here then they can find the corresponding voltage or current to the additional temperature. Okay, so maybe that is like, I don't know, 1000 degrees Celsius maybe. So he got to go and check out the exact number. I think he's trying to do that. Alright, I know you may find it's a bit frustrating to understand the principle because you don't know fully. I would say the key ideas are simply these already, like what you have to know in IGCSE. In fact, thermocouple is really rare. It's really rare. You don't really see them a lot in the past paper, but then it does, right? 1 or 2 times in 10 years. So it's a really rare question that you may see. So yeah, just in case. Alright, next up is something that finally, something you are very familiar with, I believe. So it's called the liquid in glass thermometer. We call it liquid in glass thermometer because there's liquid in it. Well, it could be alcohol or mercury. So let me just go through the names of the properties first. Okay, so that is the 4 different kind of properties you can describe whenever you have a thermometer. So the first one is called sensitivity. We'll come back to this later. The second one is called range. Range is very simple. Maybe you can just talk about it now. Range is simply the highest and lowest temperature, right, or the difference of highest and lowest temperature of thermometer. For example, mercury is -39 to 500 degrees Celsius. The reason why there is a limit apparently is something to do with their state. For example, when they get to become gas, then you can't use it anymore because it's liquid in glass, not gas in glass. Or when it's too cold, that they turn into solid. So yeah, same idea. As for alcohol, you can see that it can go deeper to negative, but then for going up, it's not easy because alcohol can again boil or evaporate easily. So for example, ethanol will have a range up to 78 degrees Celsius only. The one that we use in school is not ethanol, right? Some sort of alcohol, I'm not sure what exactly it is, but then definitely it can measure up to more than 100 degrees Celsius. That's simply the boiling point. Number 3 is something called the responsiveness, okay, whether or not it is responsive. So apparently something to do with the time, okay, how long here is not about dimension, how long, but then it's about the time, okay. That means whether or not it's quick or slow, okay. So yeah, and as in of course, like guess what, the thermometer to detect the change of temperature. So the way that you can change it is by changing the glass bulb thinner or making it smaller. So the reason is that, I mean, this is glass bulb. In case you have never seen a thermometer before, there is a reservoir where it contains most of the liquid. Alright, and this is where you actually detect the temperature, not the whole tube. It's mainly this one, and that's why if you are kind of using this to measure your body temperature, usually you put it under your thumb. Okay, and then here the idea is with a thinner glass, then the conduction can go faster. The rate of conduction can go faster because the glass in itself isn't something that you want to really transfer the heat and expand. Right? It's pointless to expand the glass. You want to expand the liquid inside. So I mean, if you could, you can get rid of the glass, but then it's impossible because that's the container. So making it thinner can make it more responsive. And lastly, it is a word called linearity. Okay, apparently is talking about whether or not it is being linear. Okay, and so for the idea here, it's talking about when you are increasing the temperature for each interval. For example, 1 degree Celsius as just a randomly picked interval, whether or not the increase of length is always the same. So for example, a good linearity would mean for each 1 degree Celsius, it will be, for example, 2 cm increase. The reason why it may not be linear, because you may be thinking, oh, of course it has to be linear. Not really, alright, in practice, because first of all, the liquid may not expand equally, alright, or linearly by itself. So it's just simply the physical property of the liquid. Maybe at the beginning they expand less, and later on they expand more at a greater temperature. The other factor that may also affect is that the tube itself may not be regular. So for example, for a not so good tube, let's say it's something like this, okay, and then let's say here is 10 degrees Celsius, here is 11 degrees Celsius. So from this you can kind of see, like, of course there must be a physical dimension, like maybe this is say 3 cm apart from each other. And if you think about the liquid, right, what happened is earlier they were here, and then when you go to a greater temperature they expand more, so that's why they can get up to here, and then they of course will keep going to later part. But then since you can see the diameter of the tube, so I'm not sure if you understand what I'm drawing. This is the inside, the inner tube. You can see that it's going bigger, and therefore normally you have that much of area, or more precisely the volume. Then now you should have the same one for 12 degree, but then since this is kind of wider, then the distance that you have should be less, so maybe it will become 2.5 cm only. And so obviously this is not going to be linear, and if you kind of zoom out and look at the thermometer, then the thermometer will be very strange that it may have. I mean, in a very exaggerated case, this is 10 degrees Celsius, 11, and then 12, 13, 14, 15, getting really cold, and that's is not something you want usually. Alright, going back to the first one about sensitivity, this is something that people usually mix up with responsiveness. Okay, sensitivity means being sensitive is different from being responsive. One could be responsive but not sensitive, as in maybe only when there's a big change, like I mean, some people could be very sensitive, like, oh, if you simply touch them they can already feel, or you simply touch their hair they can already feel. But some people, they are not sensitive, like only they will realize, oh, something happened, or feeling something happened when, say, an atomic bomb exploded. So of course, because the thermometer is not a person, so it's not judged by feeling, it's judged by how much they expand, more scientifically speaking. And if you look at thermometer, of course, it's not just about how much they expand, it's how much they go further in length, in distance. Okay, and so in order to make the distance go further, right, for the same change of temperature, what you can do is you can use a thinner tube, right? For example, here is a tube which is thin, here is a tube that is wide. Okay, so for a wide tube, let's say this is the increase of how much it goes for a certain temperature T, or 1 degree Celsius if you want to think. Then for the thin one, it's not going to be the same, because the volume again has to be constant. The increase of volume has to be constant, and therefore it's not just this, it's probably something like this much, alright, more. And therefore in terms of the length, it will increase more, so you can see more easily, and that means it's more sensitive. So other than changing the tube itself, you can also change the liquid, the material inside. Choose one that can expand more, can apparently increase the sensitivity, because that eventually will go again further in distance. So for example, alcohol can expand more than mercury. The other approach, the last approach you can do is changing to a larger bulb. So again here, you can make it bigger, so that inside the reservoir, the volume that it contains will be more. So eventually when you have the same increase, apparently more of them will increase in total, and therefore you can again go further in distance. So this will increase the sensitivity. Having better sensitivity can help you to have better interval on your thermometer. So maybe when you read it with a longer range, longer distance, then you can have more refined like 0.1 or even 0.01 degrees Celsius for a longer distance. But then for something that is not so sensitive, maybe they can only increase for a very tiny bit for 10 degrees Celsius. So that would be terrible if you look at this thermometer versus this 10.1, 10.2, 10.3, etc. So apparently this one will be better as a scientific tool.